I hope everyone's ready to take notes on decimals part 2. We're going to talk about multiplying and dividing decimals. Remember that if you need to at any point to pause or rewind the video so that you can go back and catch something that you missed or went by too quickly. In preparing for today's notes, I realized that these are the don'ts of multiplying and dividing decimals. We're going to start with, when multiplying decimals, don't line up the decimals. We're used to doing that with adding and subtracting decimals, and so sometimes we fall in the trap of doing that with multiplying. However, what that tends to do is give us more work and more opportunities to make errors. So don't line up the decimals. Multiplying decimals is going to work a lot like multiplying regular numbers, and that when I see my two factors that I have to multiply together, what I really want to do is write the larger of the two on top and the smaller of the two on bottom. Yes, the negative 7.19 is negative. And if you want to write that here, you can. Or you can come over here and just go ahead and realize that since this is positive and negative, my answer is going to be negative, and then don't let it affect your multiplying work. Put down my 0 so I can multiply by the 3 in the second place over here. Notice, since I'm done with that carry and I'm replacing it, then I'm crossing it out. I don't need this carry anymore. There are two numbers behind the decimal in the first factor, one number behind the decimal in the second factor, so that makes a total of 3 numbers behind the decimal in my answer. 1, 2, 3. So I get 28.041. Since I already have started writing this over here, I know that it's going to be a negative answer. Right? Alternatively, you could also make sure to put the negative sign down here, but you have to make sure that you remember that negative sign. Don't forget the rules of integers. One more example. My larger number is going to go at the top. Although I guess technically they have the same number of digits, we know these zeros aren't really going to affect our multiplying. So when I multiply by 1, that multiplication work is really easy. Now I just need to figure out decimal placement. 2 numbers behind the decimal here, 3 numbers behind the decimal here, makes for a total of 5 numbers behind the decimal in my answer. However, 1, 2, 3, 4, I don't have enough digits. I have to continue going to the left, adding a 5th digit there of a 0, so that I can make sure that I have enough numbers behind the decimal point. Notice I'm adding it to the left. Positive times a positive gives me a positive answer, so there's my answer. The next don't leave decimals in fractions. Don't leave fractions in fractions either. Remember, that's just another way of showing a fraction division problem. But since we're talking about decimals today, I'm going to focus on this part. Don't leave decimals in fractions. I have a couple of examples here. When I have a decimal in a fraction, I just can't leave that as my final answer. The easiest way to get rid of it is to multiply by the appropriate power of 10. Because just like with scientific notation, when I multiply by a power of 10, it moves my decimal over that many places. Since I want my decimal to move over 2 places, I need to multiply by 10 squared, or 100, and that's going to give me 17 over 1,200. 17 is prime, and I know it does not go into 1,200, so I know that's my final answer. Over here, I can do the same thing. I only need to move over 1 place, so I only need to multiply by 10 to the first power. After I've done that, though, I still need to look for simplifying. In this case, I can divide these both by 5, giving me 9/14. There is another way I could take care of this decimal in this fraction, and it's because it ends in a 0.5. I know that if I have something that ends in a 0.5 or a half, that I can double it, and that will also give me a whole number and get rid of that decimal. And you see I get the same 9/14 I had before. So, as we continue on looking at decimals and division, the next don't I want to give you is don't forget the integer rules. I already said that earlier with multiplication, but let's make sure we pay attention to it here now in this division problem. Here is my dividend. The first number is the dividend. The second number is the divisor. My dividend goes inside the house. My divisor goes outside the house. If you want to copy over the negatives, you can, but I know that a negative divided by a negative is going to give me a positive. Once that's taken care of, you might want to get rid of those signs so they don't interrupt your division work. My decimal needs to come immediately above where it is inside the box. Make sure it goes into the quotient in that same location. 11 cannot go into 3, but it can go into 30 2 times. That's why the 2 goes on top of the 30. 2 times 11 gives me 22, and when I subtract, I get a remainder of 8. That's less than 11, so I'm good to keep going. Bring down my 9. 11 into 89 happens 8 times. And when I subtract that product of 88, I get 1 left over, which is still less than my 11. So I bring down my last digit. 11 into 11 goes 1 time. And I'm done because I'm done with digits bringing down. I don't have any remainders left. So I'm getting a positive 2.81 as my answer. To double check, I should multiply my quotient by my divisor. And again, this one, since it has the most digits, is going to go on top, times my original divisor of negative 11. I don't line up the decimals because it's multiplying with decimals. I don't line up the decimals. Positive times a negative is a negative. 2 numbers behind the decimal. 0 numbers behind the decimal. It gives me 2 numbers behind the decimal in my answer. And negative 30.91 was my original dividend. So I know that I've done that all right, and that is the correct answer. It's my next don't. Don't leave decimals in the divisor. So when I have a problem and there are decimals in the divisor, I don't want to leave them that way. And I'm going to use the same kind of rules that I did before when I had decimals in my fraction. When I set up this problem, and I see that there's a decimal in the divisor, I want to multiply it by whatever appropriate power of 10 I need to move it all the way to the end. In this case, it only needs to move over 1 space, so I need to multiply times 10. Do the same thing to the dividend, just like I do to numerators and denominators. It's going to be easier for me to rewrite this problem now with my decimals relocated. Negative and positive, since there's one of each, I know my answer is going to be negative. Decimal comes immediately above into the answer. And now I've got to work on my division work. 45 cannot go into 4, cannot go into 40, but it can go into 400, and it's going to go in 8 times. That's less than my divisor, so I'm good. I bring down the 5. 45 into 405 goes 9 times. Like before, if having this negative sign out in front of your divisor was confusing you, after you put the negative sign in your answer and you want to scratch it out, that's fine. Make sure, though, that you remember this negative sign as part of your answer. Even though we kind of put it over here on the left-hand side, the answer is a negative 8.9. We can double check that quotient by multiplying it by our original divisor. Four times 9. One number behind the decimal, no numbers behind the decimal. Negative times a negative is a positive. Positive 400.5, which matched that dividend right there. Everything checks out. There's my answer. One last example. It's going to take us to our last rule of don't. So 0.97 divided by 1.1. To get rid of this decimal right here, I'm going to move it over 1 space. Move this over 1 space. So again, it helps if I rewrite it. 9.7. Decimal comes up here. Positive divided by positive. My answer is positive. Everything's good there. And then I start dividing. 11 cannot go into 9. If you want to, you can write a 0 there. You don't have to. 11 into 97 goes 8 times. Well, now I'm out of digits. However, I'm not out of number. I still have this remainder here. I need to add a 0 and keep going. Still have to add zeros and keep going. Oops. That would go in one time. Now at this point, this is going to start to seem very familiar. 90, 20, 90, 20. I'm about to get another 90. So what I have is a repeating pattern going on here. If you notice, the repeating pattern didn't start right away. I didn't have 90, 20 right away. This 8 up front is not part of my repeating pattern. But this 8, 1, 8, 1 is going to continue. And so my answer is like this, with a repeating bar over the 8 and the 1. So my last don't for you is don't round unless you're told to. Just because something starts to get long does not mean that you choose a place to round to. Either we will tell you where to round, or you need to figure out where your repeating pattern is happening and represent it with the repeating bar.